Hi dear judges, we are the Plumbers and we are here to present our wastewater management system. Here we outline the problem statement and objective that guide our development. This is our proposed process which we will explore in greater detail later. To design effective treatment solution, we must first understand wastewater sources. Domestic wastewater include groundwater from sink and shower, while black water from toilet carries waste and pathogen. Next, industrial wastewater can be inorganic with heavy metal and acid from industrial, or organic with toxic chemical from pharmaceutical and domestic. Last, stormwater runoff carry contaminant from the environment. Agricultural runoff contain fertilizer and pesticide, while rainwater and surface runoff pick up dirt, debris, and oils. Once collected, the first step in treatment is removing large debris. Wastewater static screen filter out fiber, solid, and non-oily waste. This prevents clogging and protect downstream equipment. Why we use it? It is cost-effective, operate with non-electricity, and long maintenance. It is also durable due to corrosion-resistant material, and is high efficient with precise filtration. And last is self-cleaning wedge-shaped design can prevent clogging. So, how it works? It operates in simple 4 steps. First, wastewater flow evenly over the inclined wedge wire screen. Then, after the static screen, heavy particles like sand and gravel remain. To remove this, we use the vortex grid chamber. It is a cylindrical tank where wastewater flow in tangentially, and it uses centrifugal force to separate heavy particles like sand, gravel that remain in wastewater. So, why we use it? First, it is cost-effective that operates passively with low maintenance. It is also highly efficient to remove fine grit up to 0.11 mm with 73 efficiency, and is also space-saving due to compact and scalable design. But how does it work? The wastewater is first entered tangentially, creating a vortex that pushes grit to the bottom for collection. The grit-free water is then acid, while collected grit is transferred for dewatering and disposal.
For the next stage of our wastewater treatment process, we applied iron-impregnated biochar column, which is an adsorption column filled with adsorbent, so-called iron-impregnated biochar, aiming to remove heavy metals, some organic and inorganic nutrients, as well as inhibit the growth of microorganisms. So what is iron-impregnated biochar? Before that, let's talk about biochar. Biochar is a porous carbonaceous material produced via pyrolysis, a thermochemical decomposition process of biomass with absence or little amount of oxygen. Iron-impregnated biochar is basically just biochar treated with iron-based solutions like iron 3 chloride solution or iron 3 nitrate solution, causing an addition of active sites, normally iron 2 oxides or iron 3 oxides, onto its native surface. So why iron-impregnated biochar instead of other adsorbents? Well, this is because iron-impregnated biochar has higher heavy metals absorption efficiency due to more active sites on it. Besides, it is more selective in removing phosphate ions in the wastewater. Also, iron-impregnated biochar occupies high thermostability as iron ions stabilize its overall structure. Last but not least, it promotes antimicrobial activity by disrupting and impairing the microbial metabolism. Now, talking about the general process, initially treated wastewater from the grid chamber enters the iron-impregnated biochar column. After that, adsorption processes which involve chemisorption of heavy metals and phosphate ions occurs, followed by physisorption of organic and inorganic nutrients onto the iron-impregnated biochar surface. Meanwhile, some ion exchange also occurs between H+ ions on the biochar surface and the heavy metal ions in wastewater. Finally, the treated wastewater exit the column and will be further processed at the upcoming stage. For the regeneration method, temperature swing desorptions and chemical purging using H+ based solutions like HCl solution will be applied.
So upon the completion of filtrations from the iron-impregnated biochar, the water will then flow to an algae microreactor with an open reservoir design. So in this sector, it mainly aims to do nutrient removal, organic matter degradations, carbon dioxide capture, and as well biomass productions. And aiming to prevent uncontrolled competition among species, a synergetic consortium will be introduced to enhance the overall efficiency. So now moving on with the overview of our pond designs. So for our designs, the water will be differentiated into 2 zones, namely the oxygenated zones and the exonic zones. So these zones are created by introducing a geotextile fabric in the mid-depth of the water, and in order to prevent excessive sedimentations on the geotextile fabric, a fine bubble diffusers will also be introduced as well. So in general, for oxygenated zones, the light intensity will be higher, alongside with the higher dissolved oxygen content, while for exonic zones, there will be a lower light intensity and also a lower dissolved oxygen content. Firstly, we're focusing in the exonic zones where we have PNSB and also precoccus denitrificants. For PNSB, it possesses the ability to perform denitrification process and also assimilating ammonium for its biomass growth. While at the same time, PNSB can also support the growth of precoccus denitrificants by producing volatile fatty acids, for example, such as ecatate. Not to mention, PNSB can also produce hydrogen gas that acts as an electron donor for the denitrification process. While in the other hand, we have precoccus denitrificants that has a greater performance toward the denitrification process as compared to PNSB. However, do be noticed that both of these species has a limited removal efficiency towards carbon dioxide. Now moving on to the oxygenated zones where we have Chlorella vulgaris and also Bacillus subtilis. So for Chlorella vulgaris, it is highly effective in removing carbon dioxide while producing oxygens for Bacillus subtilis. In the meantime, Chlorella vulgaris can also assimilate carbon compounds such as ammonium and other nutrients for its own growth. Now moving on to Bacillus subtilis. So Bacillus subtilis can secrete certain types of enzymes to break down proteins, fats, and also carbohydrates into simpler compounds. Not to mention, it can also produce carbon dioxide and provide support for Chlorella vulgaris growth. Additionally, Bacillus subtilis can also facilitate ammonification process by converting proteins and amino acids into ammoniums, serving as a nutrient source for Chlorella vulgaris and also PNSP. As soon as the water passes through the algae microreactor, it will then proceed with the microscreening process, which in our case, it will be gravity-based, and a fine mesh with a pore size of 60 micrometer will be implemented. So, in this process, larger bioreactors, algae clusters, and also bacterials will be filtered out as the water passes through it. With so, contaminants can be filtered out, and also it can as well facilitate the biomass recovery.
Ultrafiltration is a membrane filtering process used to remove impurities in wastewater. It acts as a physical barrier, allowing clean water to flow through while blocking impurities. We selected hollow fiber UF as it has a large surface area with pore diameters of 0.01 to 0.1 micrometers for effective separation. It can eliminate over 99.99% of microorganisms, proving its effectiveness against bacteria and viruses. It implements cross-flow filtration mode, which can reduce membrane fouling and extend the lifespan of the membranes. As the operation occurs at a low pressure of 0.1 to 0.5 bars, it requires little energy, making it energy efficient. It is gravity-driven, making it suitable for rural areas. Finally, after ultrafiltration, we utilize low-pressure UV disinfection system at 254 nanometers to destroy any remaining pathogens instantly. Unlike chlorination, this is chemical-free, fast, and energy-efficient, preserving clean water sources. It uses up 10 to 20 watts of energy per lamp and only needs minimal maintenance due to its long lifespan of 12 to 18 months. It is perfectly suited for off-grid rural areas. It is also locally available in Malaysia, ensuring easy implementation and long-term sustainability. Now, we move on to the economic feasibility. Hollow fiber UF and low-pressure UV disinfection system have moderate capital costs, whereas the remaining components have low capital costs due to gravity-driven processes and locally sourced materials. Most components rely on natural treatment methods, gravity-driven procedures, and low-energy technologies, leading to low operational costs. The maintenance cost is generally low, with only a few components requiring periodic replacement or cleaning. This system is highly scalable due to its modular and adaptable design. It is economically sustainable to low energy usage and locally available materials.
Now, let's talk about environmental impact for our wastewater treatment project. First of all, eutrophication can be prevented due to effective removal of nutrients like nitrogen and phosphorus that encourage algae bloom. Besides, water quality will be enhanced via efficient removal of contaminants, especially heavy metals and microbes. Meanwhile, public health protections can be achieved if properly treated water discharge prevents waterborne diseases. Last but not least, the ecosystem can be preserved because natural freshwater supplies can be replenished and maintained, which supports not only aquatic biodiversity but also other organisms.
There are several challenges that our project may face. Firstly, is the high initial cost, where we need to seek funds from the governments or the NGO sectors. After that is the risk of clogging, where we need to do regular monitoring and also backwashing to prevent excessive build-ups. Not to mention, we may also have challenges in terms of power fluctuations, where we need to prepare backup power for our plants. Last but not least, we may also face challenges in terms of climate resilience, where, for example, we need to install features such as transparent covers above the open raceway ponds.
That's all from us. Thank you.